Hello, and welcome to the SAP HANA Academy. The business setting is a racing company that conducts races throughout the year. They experience regular outages for at least one car during a race. This is becoming a problem. Therefore, a big topic for this motorsport team is the durability of the car and how to simplify the process. Their problem is that they need to analyze the durability of car parts and identify their vendors during the racing season. They perform tests and training rounds until a car part breaks, and they would like to use the telemetry data of these test rounds to predict future failures and to get an overview of the durability of pieces from their different vendors. They want to know which vendors' parts are the most durable ones for racing. In the past, they did trial and error, where they tried different vendors in the same race. They collected and related that data manually. There was no streamlined and standardized process to rely upon during the race and season. It would be great for them if they could get a more holistic view and visibility of the relation of vendor parts and car failures. The company streams the telemetry data during all races and keeps it in a low-cost storage on a Hadoop distributed file system. The company has an SAP S/4HANA system, which they use to store the vendor material information. The company wants to learn by using last season's telemetry data, which is stored in the telemetry archive. To begin, we'll start with the data refinery. We'll cover the ingestion from HDFS, transformation, and profiling. First, we'll navigate to the SAP Data Hub. Log in with your username and password. The raw telemetry data for the entire racing season is stored in many files on a Hadoop SAP BDS system. The format is a semi-structured JSON format. Here we can see the SAP Data Hub landscape management. We can see all the systems which are connected and the status of the task. The racing company's Hadoop system is connected and we can browse the files. Now, to see the telemetry race data, we'll click on the discovery icon and then expand the HDFS con default to see the CarTelemetry.json file. The race company needs to extract the subset and wants it in a format where they can do queries for further processing. The goal is to combine the telemetry data with material data from SAP S/4HANA. This data transformation from raw JSON into a Vora table is done via Data Hub pipeline. To get to the SAP Data Hub Pipeline Monitor, click on the rocket icon to open the Launchpad, then choose Data Hub Pipeline Modeler. The Data Hub Pipeline loads the JSON files from HDFS by using the SAP Vora client into the Vora distributed engine. From there, we use a SQL query to extract the data we want and write the result back to the Hadoop file system as a CSV file. To locate it, click on the repository sidebar and then expand Graph, and select Telemetry Data Refinery, then click on the HDFS producer. Expand this on the side to see the configuration. Here you will find the path listed. The result is a CSV file on the HDFS. To work with the data, now we will create a relational table using the Vora modeler. We do this because we need to typify our data, which means we need to add a schema or a structure. We want to typify the data so that we can do aggregations and calculations using SQL queries. Once in the Vora tools, click on the SQL button to open up the SQL editor. This query will show us the average brake temperature per car, and we'll be able to visualize that information in the data preview. Click Execute. Next, click on the Charts button so that we can configure the charts display. Change the y-axis to show sum, and then change the x-axis to display the MAC address. Then click Apply to see the sums of the average brake temperature. Go back to the SAP Data Hub and go to the Discovery section again. Expand Vora Catalog, choose Vora, and then CarTelemetry Extract. Now we can do some profiling on the data to get a quick overview of the structure. Click on Metadata to, of course, see the CarTelemetry's extracts metadata. Click on Profiling and start profiling to kickstart the profiling job. Alright, now the profiling has finished. Select CarTelemetry Extract again. Click on View Fact Sheet. Once the fact sheet has loaded, you can see some helpful information. You can also see here the range of temperature measured. Next, we'll cover the fusion with SAP S/4HANA material data and go to the SAP HANA web-based development workbench. Log in with your username and password. Now, the sensors in the car produce measurements for specific parts. The company wants to know which parts are being used for which specific car. These parts have certain specifications in which they run. Therefore, the company wants to enrich the sensor data with with material data from an SAP S/4HANA system. We'll do this by showing in Data Discovery that the SAP S/4HANA data is joined. So choose Catalog, then select the schema SAP HE4, then open Tables to explore the table structure. Right-click on the MAKT table and select Open Content. This will show you the joined SAP S/4HANA data. Next, navigate to SAP HANA XS Advanced. Log in with the same username and password you used for the SAP Data Hub. Here we want to replicate the material data specifications from SAP S/4HANA to the HDFS with the goal to enrich the sensor data. Open the SAP Data Hub folder. We want to check out 3 of the data sets by opening up data previews on them. The first set of data is B_HDFS_mat_basic. So open a data preview for it. The next one we want a data preview is B_HDFS_mat_text. And the final one is B_HDFS_mat_view. This trio of data sets was replicated before from SAP S/4HANA to HDFS for further processing in Data Hub. Now, those 3 material data tables from SAP S/4HANA will be joined together. Only some columns will be selected for further enrichment with the car data. Please expand tasks and then select C_HDFS_mat_joint. Click on the configuration wheel. Click on the execute button in the upper left area of the screen. This triggers the CSV file join procedure and will create a new CSV file on HDFS. Open that up by clicking on C_HDFS_mat_join in the datasets. We have a cross-join table that contains the information on which MAC address range belongs to which vendor. Now we will enrich the material data with the car's MAC address and the threshold. Go to the tasks again, and this time open up HDFS_J_telemet. Then click on the execute button in the top left. The results will be a new enriched CSV file with the material data from SAP S/4HANA and the thresholds for brakes, wheels, engine, shock kit. To see the results, do a data preview on the dataset D_HDFS_J_result. To relate that data with our existing data, we created a VORA relational table. This is realized by that projection. You can view this by opening D_VORA_CPART_thresh_proj from the task list. Next, we will surface data to HANA Data Warehouse for consumption via an analytical application. Now we are doing a threshold detection where output is the sensor data with threshold violations for each data record. Our end goal is an analytical app and a dashboard. Highlight the syntax, ensure the schema is VORA, and then click Execute. Now to see the data, expand VORA on the side, and then do a data preview on threshold violations. We can now surface that VORA view to SAP HANA and expose it there as an OData service for consumption in an analytical app. So go to SAP HANA Web IDE OData Explorer address for the telemetry data. Here, we can view a table of the battery voltage violations and the brake temperature violations using the OData Explorer. So how do we bring all of this together so that an end user can get some insight out of the data? Well, the answer is that we can use an advanced analytical application. Enter your SAP Cloud Platform credentials. The application is written in UI5, and as you can see, it provides an interactive view so one can browse through this data. You can look at things such as different tracks and car lists. Clicking on the bottom right button will take you to the Season Overview section. Displayed here is information about all of the car breakdowns per vendor that have occurred throughout the season. Selecting different tracks, such as Texas, shows the average lap time for each brake vendor as well as their ranking. A map of the racetrack is also shown. So the results of the telemetry data, which were enhanced with the threshold hits and outliers, were written into a VORA table. That table then got exposed via SAP Smart Data Access to SAP HANA for SAP UI5 consumption. Value proposition. SAP Data Hub acts as a data refinery, cleansing and transforming raw data before it is surfaced through SAP HANA for further and more detailed analysis. Wish to combine raw telemetry sensor data with material data from sources like SAP S/4HANA. Leverage Data Hub's pipeline modeling capabilities and use a SAP UI5 analytical application to show the detected anomaly scoring, data point outliers, and information about the vendors of the car part. cards. We will show how to use SAP technology capabilities, such as SAP Data Hub, SAP HANA, SAP Vora, to analyze telemetry data from past races. The raw telemetry data is stored in JSON format on a Hadoop Big Data cluster.